Hello, everybody. My name is Yann Garcia from FSCOM. I'm a delegate for the ETSI Multi-Access Edge Computing Industry Specification Group. As ETSI member, I'm also involved in MEC Testing Task Force 12, responsible for MEC API Conformance Testing development. Today, I'm very pleased to be able to present this episode of the MEC Tech series, focusing on MEC conformance testing. This short episode is about MEC testing with a focus on conformance testing. From the developer point of view, some basic tests to conduct during development are unit test, functional test, integration test, and load.volume test. Here we're going to discuss conformance testing in the context of MEC standardization. This episode is targeted toward MEC service developers. The main components of a conformance test suite are the requirements catalog. A requirements catalog should list all implementation requirements from the various sources and organize them into an appropriate structure. Secondly, the implementation conformance statement, or ICS. This is a checklist of the capabilities defined in the standard. When filled by the user, the ICS provides an overview of the features and options that are implemented by any given IoT. The ICS can be used to select and parameterize the test cases and as an indicator for basic interoperability between different products. Thirdly, the implementation extra information for testing, or ETSI. It contains additional information such as specific addresses, timer values, and so on, necessary for testing. In the specific case of protocol standards, the ICS is known as a protocol ICS, or PICS, and the ETSI is known as a protocol ETSI, or PICSIT. Fourthly, the test purposes, or TPs, provide an informal, easy-to-read, self-contained description of each test, concentrating on what is to be tested rather than how the actual test may be achieved. They are derived from the relevant base standards or from the appropriate requirements catalog. The set of all test purposes is grouped into a logical test suite structure, or TSS, according to suitable criteria such as basic interconnection, error handling, functionality, and so on. The standardized notation TPLAN is a good way to write consistent test purposes. Finally, the abstract test suite, or ATS, is the entire collection of test cases, sometimes known as test scripts. Each test case specifies the detailed coding of the test purposes written in the standardized test specification language TTCN3. The actual executable test suite, or ETS, can be quickly and easily implemented from the ATS using the TTCN compilers available on many test platforms. The purpose of the conformance testing is to determine to what extent a single implementation of a particular standard conforms to the individual requirements of that standard. For a developer, the standard can be a set of software or product specifications or a set of standards. The problem is to be sure that an implementation is compliant with the standards it implements. Here, we are considering MEC standards such as MEC 10-2, MEC 11, and so on. One solution is to use conformance tests against the implementation. There are three main reasons to conduct conformance tests against an implementation: to check for the system requirements fulfillment, to check the development, design, and evaluation as per specification and standards, to minimize the risk interoperability between MEC services and MEC applications. The conformance testing can be done manually, for instance, at the end of each Scrum sprint cycle, or it can be integrated to the CI/CD chain. ETSI MEC conformance testing can be virtualized in a Docker image and integrated in the test stage. Conformance testing process is necessary to ensure efficiency, performance, and to avoid future risk for a software application. An effective conformance testing includes following step-by-step process. Analyzing standards and specification. Here we are considering the MEC standards. Selecting test tools and test suite. ETSI MEC Conformance Testing API uses two different testing tools, TTCN3, developed by ETSI, and Robot Framework, which was written in Python. Thirdly, designing testing procedures, checking necessary validations, and finally, adapting relevant testing policies and certifications. The ETSI ISG MEC Decode Working Group has developed a set of conformance test suite for MEC service developers. This test suite covered the following MEC standard. MEC 10-2 Application Lifecycle Management, which define management of MEC applications such as lifecycle, application policies, and so on. MEC 11 Application Enablement, which define a generic framework between MEC applications and MEC platforms. MEC 12 Radio Network Information, which provide information on current radio conditions. MEC 13 Location Service. MEC 15 Traffic Management, which provide bandwidth management service and multi-access traffic steering service. MEC 28 VLAN Information Service, which provides VLAN access-related information to services. MEC 29 Fixed Access Information Service, which provide fixed access-related information to services. And finally, MEC 30 V2X Information Service, which provides information to MEC consumers in order to facilitate V2X interoperability. This was a short introduction on MEC conformance testing. So, to wrap up and conclude this episode, here is what we have learned. First, what is conformance testing in theory? Secondly, a methodology to conduct conformance testing against a standard implementation. And finally, some MEC conformance test suites are already available and ready to use at ETSI. I encourage you to visit the ETSI Forge. An ETSI webinar will be available in the coming months for advanced developers and testers to demonstrate conformance testing against the MEC sandbox. So, finally, thank you for your attention and interest in MEC conformance testing. I hope you'll continue to enjoy the rest of the MEC Tech series.